Good evening, everyone. Shall we start the class? Can anybody reply?
Yes.
No. So, happy Republic Day to everyone first. This is the first ever TA session for the course on maintenance and repair of concrete structure. So, I am your TA and my name is Shefali Agarwal. And every Friday we will meet at 6 to 8, from 6 to 8. And what we will basically do in our session will be we will be solving some questions related to the topics which you have read in the week before. So today is the first ever TA session. So we will have a simple MOOC session where I will be having some questions, and mostly those questions will be related to your basic knowledge in civil engineering, not much related to the course. So if you have any doubt, just put it in the chat box. We will discuss all the doubt after the session. Okay. So I will start the class now. Can you see my screen?
Yes, ma'am.
Okay. So we will have some basic questions and we will discuss them. It's an interactive session, so please feel free to reply to all the questions. It will be very nice if you would interact with me more and more. So the first question, the important books which I think sir have already told you about these books. So you can go through these four books for this course. And so this is the first question. Consider the following concrete mixes. We have four type of concrete, all M30 grade. And first is M30 grade concrete designed in Jammu at a temperature of 4 degrees Celsius and 50% relative humidity. Second type of concrete is designed in Jammu at 4 degrees Celsius and 100% relative humidity. Third question is designed in Chennai at 25 degrees Celsius with 100% relative humidity. And fourth is designed in Chennai at 25 degrees Celsius at 50% relative humidity. Based on these four type of concrete, please see the options and tell according to you which options are the correct options. Please read the options. First is compressive strength of concrete A is more than compressive strength of concrete B. So difference between A and B is mostly of the relative humidity. Same if we see the option number B is concrete strength of concrete B is more than strength of concrete A. Option C is strength of concrete C is more than strength of D and P. And option D is compressive strength of C is more than compressive strength of D. Take 2 minutes, and if anybody know the answer or you can guess the answer, please reply. Ready? Gayatri, Shrenik, Pooja. Anybody who want to guess the answer? Okay, first let's see what is the difference between uh, all four types of concretes. First two are made in Jammu, and the difference between them is the relative humidity difference, right? So more the relative humidity, less is the chance of water to evaporate, and more will be the hydration. More the hydration, more will be the compressive strength. So based on this thing, we can say the compressive strength of B will be more than the compressive strength of A. Okay, same way we can see the compressive strength of C is more than compressive strength of D, right? So option B and D are correct. Next is option A is completely opposite than B, so it's wrong. Option C is compressive strength of C means a house built in Chennai at 25 degrees Celsius and 100% relative humidity is more than strength of B and D, more than Jammu and Chennai. Difference is temperature and relative humidity. More the relative humidity, more will the strength. And with more the temperature, more hydration will happen and more will be the strength. So the accepted answer or the correct answer will be B, C and D. Is it clear with everyone or does anybody have any doubt in this question? Anybody reply yes or no? We'll go to the next question then. So next question is match the columns. We have two columns and first is about the different type of problems we face in concrete and second is the reason why this happened. So column A, hairline shrinkage gap. What can be the reason for shrinkage cracks? Next is okay. You can, sorry, no ma'am. Uh, can you tell what did you not understand? You can speak. I think you can unmute yourself and speak. Okay. So next is hairline shrinkage gap, flexure cracking on concrete, decracking and alligator type cracking, surface scaling and spelling. And based on these type of problems, what can be the reason? First is reaction of strained quartz crystal with NaOH present in the pore solution. Second is evaporation of water from the concrete within 24 hours from the time of placing. Third is cycling freezing and thawing of ice trapped inside the concrete pores. And last is increase in the volume of stirrup reinforcement due to corrosion. So, can anybody guess the answers?
Hairline crack occurs due to evaporation of water only. That
Okay.
is for A, it will be 2. And
Me.
for flexural cracking of concrete, should be like freezing and thawing only.
Texture cracking can be due to freezing and thawing. Okay, fine.
Freezing and thawing, yes. And I am not sure about decracking. I have not heard of it. And
Decracking.
spelling
Okay. Okay. First speak.
and the spelling of cover is due to the corrosion of reinforcement.
Yeah.
Yeah, that is the only answers I know.
So on the roads, you might have seen these kind of like if we have a pavement, we make a slab. On slab, you might have seen corners will go like this. We will have some cracks on this corner and on this corner. So this actually is making a shape like a D. This I am showing in this direction. So on slabs you will have corners, you will have some cracks, and you will have straight kind of crack. It will be like a dip. A dip will be there on the slab. That is actually a deep cracking on concrete. I hope you are getting it.
Yes, understood.
It's
So
because
what
mainly
alligator
of
cracking?
alligator cracking is like you see the scales on the alligator, no? Mostly like in a
Uh,
undis like undefined way you will have some. These are the alligator cracking, like map cracking or alligator cracking.
okay.
Okay, so these are anything else you are not understanding here?
No, these are the only two I didn't understand.
Okay. So what can be the results? First, as you have said, hairline cracking is mainly because of evaporation, and flexure cracking because of freezing and thawing, and decracking is mainly because of reaction of quartz crystal with NaOH present in pore solution. And sorry, it's alligator cracking. What is happening because of this reaction? We are the pore solution, the moisture is getting removed from the concrete, and because of the less moisture availability, you are getting this different, like we will say, map kind cracking. So that is because of reaction of NaOH with quartz crystal. Next is the surface scaling of concrete. It's because of the when freezing and thawing happen, that time also you will have expansion and contraction. And because of that, there is surface scaling. Surface can be removed from the concrete. And last is spelling, as you have said, because of the corrosion. Okay. Shall we go to the next question?
Excuse me, can you just explain that alligator cracking once more, if you don't mind?
Alligator cracking, as in how it look like or why it's happening.
No, why it's happening? Actually, the reason, like the reaction of NaOH with the quartz crystal is reason for that. But you told that because of that, the water evaporation happens, right? Am I right?
Yeah, reaction of quartz crystal with the NaOH present in a pore solution. So pore solution mainly consists of hydroxide, right? Sodium hydroxide, calcium hydroxide, and potassium hydroxide. These are the main components of our pore solution in concrete. So when quartz crystal reacts with NaOH, what is happening? Our hydroxides are getting consumed. Because of the consumption of hydroxide mainly, you will see that the pore solution composition is changing. It's how to explain it? Because of consumption of hydroxide mainly, your water consumption will increase, and which will cause a cracking on the surface of the concrete. It's making an it won't be in a specific position. It's in the complete concrete. That's why that shape is like like map kind of shape. You won't understand that. Normally, you would have seen. Sorry.
Got it, got it. So it must be like during the initial period of curing
During
the.
the initial period, because of you, if you are not curing it properly.
And ma'am, regarding the decracking, it must be like appearing as of I understood, it must be like depression. Is it? Am I right?
Depression,
Depression
yeah.
and
It's mean it can be due to subgrade also decracking. If your subgrade is not proper, it can be due to that, and it can be due to because if you have 2 3 slabs in attached, and that slab expansion contraction will take place, so that stretch will be there, and that stress will cause the these type of cracks in the corners, this type of cracks in the edges of the slab. So it's making it
all good,
okay.
all good, ma'am. Thank you.
Okay. So just a minute.
Ma'am, just one more thing.
Yeah.
Just this surface scaling of concrete. Do you have any images of that? I have not encountered this so far.
Surface scaling of concrete.
Yes.
Um, I will show you it. But I can explain you if it's fine with you. Like when expansion and contraction happen during freezing and thawing, what is happening? When water is freeze, there will be expansion. So concrete at the top surface of the water, there is that will go up, And then that water, when during the thawing period, that water is completely melted. That will create a gap between the top surface of the concrete and the bottom surface of concrete, right? So because of that, the top surface of the concrete, it will get removed. That is exactly actually the surface scaling of the concrete. I hope it's clear.
So it is almost similar to that of abrasion that happens in
Abrasion here. But in abrasion, you will see that you can actually see the aggregate particles.
yes.
Yeah. In surface scaling, you won't see the aggregate particle. It will be like complete top layer will be removed.
Okay, understood.
So can I go to next question?
Yes, ma'am.
Yes, ma'am.
Okay. So next question is choose the correct statement. SCM. You know SCM, supplementary cementitious material, contain crystalline silica. Next, pozzolanic reaction produces more CSH, and pozzolanic reaction can occur without water. Use of SCM enhances the chloride diffusion of concrete. So according to you, what are the correct statements? To try. First, tell if anything is not clear about these statements like SCM, pozzolanic, CSH. Is there anything you are not clear with?
That SCM,
SCM is supplementary cementitious material like fly ash, silica fume, GGBS. Any idea, according to you, what can be the correct statement among all these four?
I think it is D
D,
because of
sir.
the SC
And
enhances the chloride diffusion coefficient of concrete.
okay, so you know about chloride diffusion coefficient, right?
Ah,
So when we are using SCM, we are saying our strength is increasing. How our strength is increasing? Because our concrete is more compact now,
right.
right?
Yes,
If our concrete is more compact, that there are less chances that chloride will go inside concrete.
yes, yes.
So it is a wrong statement.
Wrong statement.
Any other guess? Okay,
It
well,
should be like
huh,
option B.
option B.
Pozzolanic reactions produces more CSS.
Yeah, true. So why, how is this happening is during the cement hydration, we have two products forming. One is CSH, one is CH, calcium hydroxide. So when we have a pozzolanic reaction, if more silica is present in our concrete, there are chances that that amorphous silica will react with the calcium hydroxide and water present in the concrete and will produce more CSH. That's why we say na, when we are using SCM or silica fume has the maximum strength. Why? Because more CSH is forming in silica fume. More the CSH, more the compact will be the structure of the concrete. Okay? Is this question clear to everyone?
Yes, ma'am.
Yes.
Next question. The compound which is highly expensive and causes cracking in concrete during the process of sulfate attack is to this.
And what does it mean that D option acting
Ettringite which is present in C because of C3. Ettringite are needle-like structures.
needle like structures?
Yeah. to the answer then. It's the entering guide only. So what is happening during sulfate attack? You have read about sulfate attack, right? Okay, in sulfate attack, we have just a minute. So,
Yeah, Revati, can you unmute mute yourself, please?
Right.
yeah. So mostly sulfate attack is in the area where more acids are more the acid, more will be the sulfate attack. It's because of the sulfate ion present in the pore solution, that is internal sulfate attack. And external sulfate attack is because of when concrete is designed in the what we say marine structures, or mostly structures which are near the drainage area, the drainage pipe mostly, which have more the acids, more will be the sulfate, external sulfate attack. It is because of the, sorry, uh, when C3A reacts with the sulfates, it form ettringite. Uh, is it clear or should I explain more? Ettringite, you know, na? It is an, sorry.
It was not that clear. Please explain.
Okay. So we have four main components of cement, right? C3A, C2S, C4AF, and C3A, right? So when C3A reacts with the sulfates, maybe it can be internal or external. So ettringite will be forming. And normally when C3 is reacting with water, the ettringite which are forming is forming before the concrete set. So, but when sulfate attack in the concrete, this remaining C3A, they will react with sulfate and ettringite is forming. These ettringite are like needle-like structure. So, because of these needle-like structure, what is happening? The already set concrete, it will have expansion, right? It will cause expansion. The ettringite will cause more expansion, and because of that, cracking will be there.
Yeah, clear, clear.
Clear, no? So next question is, which are the following are the strategies to prevent sulfate attack? If we have to prevent the sulfate attack, what we can do?
Excuse me, ma'am.
Sorry. Huh?
Yeah. Ma'am, in the sulfate attack also gypsum is forming, na? So how can
Gypsum?
we distinguish?
Huh?
Yeah, with reaction of sulfate ion with calcium hydroxide. So how I will quantify which volume is higher among gypsum or attringite?
Gypsum is
Because
forming,
gypsum
but
also have a, yeah,
but it
gypsum
is
is
not
also kind of
expensive in nature.
not okay, but that much I know, like attringite is same needle-like structure, but the aspect ratio of attringite is higher because it is to like length is more, but gypsum is looking like small in size, but its volume is diameter is kind of high.
Diameter is high, but gypsum can take up the space which are already present in the pore structure of the concrete. But with ettringite, it is a very solid kind of thing, so it will cause expansion. Gypsum won't cause any expansion in the concrete.
Okay. Uh,
Is it clear?
yeah. Okay. Fine. Mm.
Next is how can we prevent the sulfate attack? By maintaining low curing temperature or high water cement ratio, use of cement with low C3 content, and use of SC. What can be the strategies?
D, use of SCM.
Any other person who want to comment?
Both C and D.
So yeah, there are three things. curing temperature. Curing temperature, if curing temperature go above 70 degrees Celsius, there is chances of internal surface attack. Okay. And next, as we have seen, as I have told you, more the C3A content, if C3A will be there, there are chances C3A will react with sulfate and will cause the formation of ettringite. So lower the C3A content, better will be the prevention in sulfate attack. And D, as we know, if we are using SCM, we are making our concrete more compact, and we are also SCM will have less of C3A content. So accepted answer are the three, A, C, and D. Is it clear?
Ma'am, if the curing temperature will be low, then the strain gain also be low, na? So then if the
Uh,
strain gain is
yeah,
low,
but
then the microstructure is looser.
maintaining low curing temperature means it should be in a range. It should not be too high curing temperature. Like when even we are doing steam curing also, and sometimes we are doing water curing, right? It's like we should maintain the exact curing temperature. It should not go beyond 70 degrees Celsius. If it's going beyond 70 degrees Celsius, then it's the issue.
Yeah. Then the statement is not properly clear, means it is not mentioned anything about the range. So if a concrete prepared cured at 30 degrees Celsius and another is cured 25 degrees Celsius, then obviously the concrete which is cured in 30 degrees Celsius, it will gain higher strength
Highest, yeah.
because of the early rapid hydration reaction initially.
Hmm.
But in that case, then that answer would be wrong, I think.
Okay. Okay. So you are saying that that option can be more better, can be written better.
Means it
Yeah.
is not, yeah, yeah.
I, I will
Anyway,
keep that in mind.
other two options are correct. Okay, yeah, yeah, yeah.
Yeah. Okay. Thank you. So can we go to next question?
Yes.
Next is the for the construction of an underground sewer pipe in an industrialized area, which type of cement will you recommend? OPC cement, calcium aluminate cement, low C3A cement, or rapid hardening cement? Ready? Want to guess the answers? One option we have already talked in last two questions, right? C3A, because sewer will have more the acids, more the sulfate attack will be the reason. So C option we can say that lower the C3A cement, better will be the concrete in regards with sulfate attack. Any other option you think can be right? To guess? Okay, then we'll go to the answers. B and C. Calcium aluminate cement and low C3A cement. You know about calcium aluminate cement. Have you read about it? Anybody know about it? So it's a special type of cement which is mainly consists of calcium and aluminate content. It won't have silica, much of the silica in it. So calcium aluminate cement, the advantage of this kind of cement is the particle of the cement is very small. So smaller the particle, more compact will be the pore structure, the structure of the concrete. So because of that, we can say that it will prevent the intake of all these sulfates or any acid attack on the concrete. So it can be used in the industrialized area. Is it okay? Okay. So we'll go to the next question. Choose the correct statement. ASR is alkali silica reaction. Alkali silica reaction can occur even if moisture is not present. Opal aggregates contains reactive silica. Dosage of lithium can influence the degree of ASR mitigation, and only moisture and reactive aggregates are needed to cause alkali silica reaction. Anybody want to guess the right answer about alkali silica reaction? You guys know about alkali silica reaction? Anybody who have never heard about this thing? Me to explain about ASR.
It's better to explain.
So what is happening if our aggregate present in the concrete have active silica present in this? Like we know our pore solution of concrete have alkali content. We have pH more than 13, right? And if our aggregate have active silica present in it, and our pore structure of the concrete have more alkali content, so there are chances that at the surface of this the silica present in aggregate will react with the alkali content present in the concrete, and they will form the ASR gel. And this ASR gel is mostly formed on the surface of the aggregate. So first this ASR gel will be formed on the surface of the aggregate, and then because it's expensive in nature, it will flow through the structure of the concrete and will cause the cracking. Okay? Is it, can you understand it? So no?
Yeah, it's clear.
Okay. So what can be the correct statement?
What is opal aggregate? No,
It's a type of aggregate only.
okay.
Go to the answers. Opal aggregates contains reactive silica. More the reactive silica, more will the ASR, right? And third is lithium can influence the degree of ASR mitigation. If lithium is present in the concrete, there are chances that it will react with the alkali content, and that it will prevent the ASR reaction, because the lithium will react with the alkali present in the concrete. Okay. Go to the next question then.
Okay.
Next question, say a similar question. You have to choose the correct statement. Rate of shrinkage decreases rapidly with time. Carbonation shrinkage is high at higher reactive humidity. Addition of fibers can help to prevent moisture loss and reduce plastic shrinkage. Addition of fibers prevents shrinkage by crack bridging action. Shrinkage, you know, right? Because of removal of water from the concrete, there is chances of shrinkage in concrete. We have different type of
ACD is correct answer.
ACD. ACD. A is rate of shrinkage decreases rapidly with time, right? Because at initial timing there are chances that more the free water will be present, and more will be the shrinkage. With time we have very less of free water present, so rate of shrinkage will decrease with time. C, addition of fibers can help to prevent moisture loss and reduce plastic shrinkage. So how can fibers prevent moisture loss and reduce plastic shrinkage?
Sorry. I have never seen the moisture loss. Yeah, it is wrong.
It can be correct, it's not like completely wrong. It,
Yeah, means it reduces the shrinkage, but not because of the loss of moisture.
and addition of fiber prevents shrinkage by crack bridging action. This is right. Okay, so the right answer are A and D. It's clear with everyone, no?
Yes, ma'am.
This is the last question for today. Effect of shrinkage and creep of hardened concrete is shown in figure 1. This thing you have seen this graph before, right? Everyone might have seen it. Shrinkage and creep graph. Match the strain responses A, B, C, and D with time of the 4 exposed condition. In first exposed condition, means the top layer is covered and this part is exposed. Secondly, this part is covered and top layer is exposed. Here, this part is covered, top and bottom layer are exposed and load is applied on the top and bottom. Here, this part is exposed and this part is covered and load is applied in the vertical direction, top and bottom. So, according to you, what matches what? What is A, what is B, what is C, and what is D? Any guesses? We can say that mostly A and first and second is because of the moisture loss naturally. So they both are shrinkage problems. And third and fourth is because of the load applied. So they mostly are the creep problems. Right? This is clear to everyone. Creep is mostly because of the loading and shrinkage is naturally happening. This thing is clear to everyone, right? Can anybody say yes or no?
Yeah, it's clear.
So, from this graph, can you tell which one is creep and which one is shrinkage? First, you understand the 4 exposure conditions. First and second are mostly because of shrinkage, and third and fourth is because of the creep, right? So, here is the because of shrinkage, the strain will be lower as compared because of the creep, because creep is under load. So we can say that more the load applied, more with the water loss. So more will be the strain. So these two cases, strain cases, are the graphs which have more strain, and these two shrinkage graph will have the lesser strain. So how we will differentiate between these two parts is autogeneous shrinkage and drying shrinkage. Can you understand these things? When when we cast a cylinder for the creep or shrinkage testing, what we do, we apply foil on the 4 sides. Right? We keep the upper and bottom layer exposed. That is the normal cases when we do in the lab testing. So that is, in that case, what we are measuring autogeneous shrinkage or basic creep. If we apply load, it is a basic creep, and if we are not applying load, it is a autogeneous shrinkage. But in other cases, when the sides are exposed and top and bottom surface are sealed, that time the shrinkage will happen from this part, right? So that is a drying shrinkage trend. And same case, if we are applying load to this, it will become the drying creep. Are all the 4 cases understood to you?
Not exactly clear, ma'am.
What is not clear? Please tell. Completely, should I explain again? Explain to you.
Please, ma'am.
Sure.
That's what.
So, firstly, we will see the graph only. So, graph is between strain versus curing time, age time. Okay. So, we have 2 cases. First, we are sealing it from the sides and keeping the top and bottom surface exposed. Other cases, we are sealing it from top and bottom and sides are exposed. So, based on the surface area, you can see that more shrinkage will happen in this case, right? More water loss will be in this case when the side are exposed. That's
Yes.
that is clear to you, right? So in this case, the shrinkage will happen from bottom and top. So that shrinkage is called as autogeneous shrinkage. So that is very low, the because very less surface area is exposed. In this case, more the surface area is exposed, more is the chances of the shrinkage, more is the chances of the loss of water. So that is the drying shrinkage. We'll call is that as the drying shrinkage strain. And
Understood, sir.
you understood, na? And why this graph is starting from this point that you know?
No.
So till this time, it is the curing period. Till here, we are curing it in normal condition only. After curing, we are measuring the shrinkage strain. In this case, the shrinkage strain is very less, that it is almost near to the after curing. What is the strain? It is similar after the certain age, let's say it's 56 age of 56 days age. After 56 days from the curing period, that strain is almost similar, constant. That will be the autogeneous shrinkage. But when the surface area is more, the shrinkage will be more. So they after curing, that shrinkage strain will increase and creep. What we are doing after curing, we are keeping our concrete under loading. So there, when we load our concrete, instantaneous strain will be there, and after instantaneous strain, again the same procedure is followed. When we are exposing top and bottom surface, that creep is almost constant, the strain is almost constant, so it is called as basic creep. But when we are exposing the side surface, the more will be the surface area, more will be the water loss, and more will be the shrinkage strain. Sorry, creep strain. So this graph is clear to everyone, right?
Yes, ma'am.
Yes.
Okay.
So you mean that if the more the surface area is exposed, the more the
Chances
shrinkage
of
process is
shrinkage.
going. That's all.
Yeah. More you will have loss of water. So since this was the first lecture, so I've prepared only less question and it's just basic what we have studied in our graduate courses. So that were the questions. And if you have any doubt or regarding complete course, you can contact me. These are my mail IDs. You can contact me in this mail ID anytime you want. Thank you. And now we can have some questions if you guys have. Sorry, I didn't read your chats before. So if you have any question, you can ask me or you can put in the chat box also. If you have any question regarding my presentation or regarding course completely or all you are studying in the course in the Nptel course, you can ask me.
Ma'am, one, like, it's no doubt, just a query. Uh, like after 20 days, the drying shrinkage is there. After curing means when the specimen is exposed from the side, the drying shrinkage is there.
Yeah,
And whether during drying shrinkage, autogeneous shrinkage is also happening or not?
autogeneous shrinkage is also happening. That's why that graph is going just above this thing. That drying shrinkage graph is going above autogeneous shrinkage. It's not starting from this point, right?
Yeah, yeah. Means the specimen 2 means which is exposed from the side, it is both experiencing from the autogeneous shrinkage and drying shrinkage.
Yeah, this
Okay,
specimen is experienced this much strain, complete this much strain.
yeah.
But this part is called as drying shrinkage strain only.
Drying shrinkage. Okay,
Hmm.
okay, okay. Understood.
Strain is completely this much.
Okay, yeah, yeah. Got it.
And so I went out.
Ma'am, can you see the last slide means the email ID of yours? Yeah, yeah, ma'am. Thank you.
Please suggest book. Okay. I've given the books in the course itself. These are the important books. I think sir have also shared with you. You can take screenshot
Can you
or
share the ACI code and the textbook because we are not able to download that one.
ACI code.
ACI code, the code which sir suggested. I don't know the 262. I forgot the code number.
Number, can you send me the code number? I will share with you. Or in next lecture, I will share with you.
Just a minute, give me one. ACI 562.
ACI 562. Okay. Or
Assessment, repair, rehabilitation of the existing concrete structure.
so, how should I share with you? Should I? You mail me?
Yeah, I will mail you.
Huh. I will share with you.
Okay, yeah. Okay.
Ma'am, although we have already read that manual and all, I'm attending this for the first time. So if you can just brief me about this, like course pattern and details, it would be helpful. Like how it will be working, like how is the schedule weekly, like how is the classes going to be holding and all.
Okay, so classes, they are the pre-recorded lecture, right? You know that thing. So, in first class, sir might have explained you about the complete schedule, how it's going to be. Like week one, it's mostly about the introduction part and corrosion part. What basically is corrosion and what are the type of corrosion. Then it will go slow. It will start with corrosion, how different type of steels are there, different type of concrete affects corrosion. Then it will go in the repair strategies. What are the how repair is being done, what are the different type of what are the different steps which should be followed, visual inspection and everything, and what are the basic tests we can do, and through the end it will go through the service life estimation of the of the structures. So it's a very engaging course. I think you should you should just watch this lecture first, and you will find it very interesting. If